So before we start our programming, let's get some of the commands that we use, or the some of the the syntax for this assembly or the MIPS assembly language. So this is how we create the command using the hashtag symbol. These are the directives. As you can see, we can create, for example, data or ASCII Z or global or text, etc. So these are the dot, and then the data is similar to the what we have here, dot data or dot ASCII, etc. We have the certain operations, for example, the addition, and then we have the multiplication, division, etc. So this is how we're going to write them. This is just some of the examples. And then when we want to refer to the registers, we're going to use this symbol here. So this is the register numbers. Okay, so if you look here, every register has its own number, so we can register through these numbers. Okay, then we have the address label. So the thing is, here, as you can see, we can create the label. In this case, we create the label for this variable here, right? So this one is called the age. Also, we can have label for our program. For example, we can put, for example, here we can say the main. So, and then we start adding some lines of the code. So now we create the label for our code. So inside our code, we can have, for example, multiple labels. For example, we can have the main, and then we can have for example, the loop, and then we can have, for example, and, etc. So we can create the multiple lines, and each line will indicate the beginning of the certain part of our code, and then we can refer to that part of our code by this label name. So this is how we create the labels. So we label name, and then as you can see, this is a double dot, and then we can use them by just calling these labels. We can create the integers. As you can see, integers could be in a positive, negative, or also the integers could be in a hexadecimal form as well. Strings we can create with a double quotes, and the characters we're going to create with a single quotes. So this is how we're going to create the program. Okay, now we can actually manipulate the registers. So first, let's learn how to manipulate the registers and some operations related to that. So for example, we can use the command li. So li means the load immediate. So in this case, we can load some constant into the register. So let's see some example for this. So let's say I'm going to erase this part. So let's keep the main part. I say the li. For example, we're going to load the register T0, and then we can put the value. For example, I want to load the integer 5 to the register T0. Okay, so let's save this one and pay attention here on the right side. Right now this is the register T0 and its value is equal to 0. So I can just click the execute, or I can do the step by step. So I'm going to choose a step by step. So I have only one instruction to run. As soon as I click, as you can see, the value of the T0 is equal to 5 now. So this is in a hexadecimal form, but in hexadecimal and decimal, 5 is 5. Okay. If I change this, for example, let's say that if I do the li, and then let's say the T1, and then I say 10, for example. So this time I want to put the value 10 inside the register T1. Okay, so let's execute this again. So I first execute the first line. I click this one. So as you can see, T0 is equal to 5, and then I execute the next line. I click like this, and as you can see, next line, the value inside the register is equal to A. Why A? Because in hexadecimal form, 10 is A, right? So I hope you remember the hexadecimal. So in hexadecimal, we count from the, we start counting from the 0, and then 1, 2, 3, 4, 5, 6, 7. And then starting from the 8, we have the 8, 9, and then we have the A, B, C, D, E, F, etc. Right? So this is how we're going to count in a hexadecimal. So in this case, 10 is equal to A here. Okay. So also we can load from the the word from the memory. So in this case, label indicates the label of the memory, the data that we store inside the memories. Okay. So for example, here you can see that I created the program. In the data part, I created two variables. First one is name, second one is age. Okay. Now in the execution part, in the program part, first I'm loading the value of the 2 to the register T0, and then value of the 4 to the register T1. So for this one, I'm using just the load immediate command. But also I can load from the memory. In this case, I have two different types of the commands. First one is called the LA, load address. So in this case, what I'm doing is, as you can see, it says the LA, so I can actually type and it will give me the hint. So LA, it says the load address. Okay, so I have to indicate where I want to load it. So in this case, I'm using the T1, right? And then where from I want to load it. Usually here I have to put the address of that register, but in this case I'm using the label. So label in this case indicates this data here. Also I am using the LW. LW means the load word now. Word is as you can see, the integer number in our case. So load word, and then I'm indicating the where to load this word, and then the label. So again, this label indicates to this data inside the memory. Okay, let me execute this program now. Save this one. So I'm going to execute one by one. So first I'm going to load the 2 to the register T0. As you can see, the value equal to 2. Next, the value equal to 4. Next, I'm going to read the name, the value of the name to the register T2. Okay, I'm going to read it. Okay, so let's read it. But in this case, it reads the address, not the data itself. So this one we have to make clear. Okay, so when we use the LA reads the address of that variable, not the variable itself. So in our case, for this one, for example, my name is here. If you remember, my name is here, Anwar, right? And this is the address of this memory. So 1, 0, 0, 1, etc. And if you look inside the T2 register, you can see the address of that of this location. So address is 1, 0, 0, 1, 0, 0, 0, etc. So when we use the LA command, so when we use this LA, we are not loading the value itself. We are loading the address to that value. So I hope it's clear. So we go to the next stage. In this case, we use the LW. LW now will read the word. So that's why if I execute this one, you can see the value of the T3 is equal to 26 now. So 26 is actually the hexadecimal value for the 38. Okay. So when we use the LA, we are reading the address of this variable. When we use the LW, we are reading exactly this value itself. So 38 is coming to the register T3. Also, we can copy the registers by using the command called the move. So in this case, if I use the move, what will happen is the value from the T2 will be moved to the T1. So I can do it here. For example, if I say the move, and then I say, let's say, for example, I want to move the value of this T1 to the register T, for example, I'm going to use the T6, okay, and then let's say the T1. So what I'm doing here is I am moving the T1 to the T6. T1 is equal to 4, T6 is right now is 0, right? So in this case it's 0. So now again I will save and execute this program. So let me come to this stage. Okay, so when I execute the move part, if you look here, move, I will click the move. So as you can see, value of the T6 becomes equal to 4 here, 4. So same as the value of the T1. So this is how we're gonna copy the registers value of the content of the one register to another register.